So as Catherine so nicely introduced us, the topic today is bridging the gap between science and research through gateways. So we're going to go ahead and start the panel by introducing our panelists today. So I'd like each of you to tell us a little bit about what you do, what your life is like day to day in science gateways, and did you dream to become a gateway developer when you were a kid? So Alex, we can go ahead and start with you.
So my name is Alex. I work at TACC, as all of us do. Day to day, I work on a number of projects at Exceed, Chameleon, TACC User Portal, all with different sets of users, although sometimes there's same users across portals. But certainly there's a lot of similarities, a lot of differences. And I suppose day to day, it varies from maintenance, support, and working on new features.
Yeah, hi, I'm Joe. I guess I've been at TACC for like 2 years, and I kind of got here on a random route. So I started off in academia, actually, and yeah, just didn't really want to do that. So decided to go to software and just kind of randomly moved to Austin, and worked in startups, did contract work, and then yeah, I got to TACC about 2 years ago. And yeah, day to day, I spend about probably like 20% of my time reviewing code, and probably about 30% actually writing code, and then the rest meetings and maintenance, things like that.
Hi, I'm Carrie. I'm also a portal developer at TACC. I've been there about 6 years. I guess my day-to-day is pretty similar. It's, you know, I have 2 major projects, SD2E and Exceed, and I spend the majority of my time on both of those. I also work on the XRES project. So it's a lot of similar user base, but a lot of writing code, a lot of answering help tickets, you know, maintenance and stuff like that.
Hi, my name is Josue. I did not dream to be a gateway developer, but that's because before coming to TACC, I've been here for a little bit over 3 years. I didn't even know there was such a thing as science gateways or gateways. But I find it really interesting. There's always very interesting problems to solve. Not all of them, as they were saying, not all of them has to do about writing code. Some of them is just about thinking about the future. Some of them is about maintenance, or some of them it's about using an already available feature, but just in a slightly different way. So that's also kind of basically like my day to day.
Hi, my name is John. I've been at TACC for a little over 7 years. My background is actually in biomedical engineering. So, you know, dreaming of portal developer. I'm still not a portal developer in a way. I'm kind of the wild card in this panel, but my background is in looking at protein polymer interactions. And I decided that I liked the computational side more than smelling the flammable chemicals fridge. So I kind of discarded the experimental, have been at TACC for a while, and really have been sideswiped into the portals domain because it's a lot easier to build a portal for a user community than to teach all of the life sciences community how to use HPC and the computational resources that they need. So it's technology as a bridge into tricking them into doing all the right things on the back end. Day to day, I do a lot of work on the back end of you know, the scientific workflows that people do, and working with the APIs and sort of architecting the solutions to different domains. I've been involved in half a dozen portals projects, everything from, you know, a real simple portal that does assist in virtual screening for drug discovery to real full-blown infrastructure for synthetic biology and for plant biology to everything in the middle with immune repertoire analysis. So it feels like a big spread to me, but in a way, all the experience that I have is in the life sciences space, which is really trying to you know, build technology for people who are not command line savvy and who have, at the same time, some very complex requirements in being able to solve their emerging challenges, right? It's always front, you know, kind of cutting edge stuff.
Thank you, guys. So the cube is over here. So if anyone has questions during any of these slides, feel free to sort of come up here. I'll toss it to you, and then when there's a break, you can ask your question. So kind of building on what John said with regards to dealing with stakeholders. What do you think are some of your biggest challenges with dealing with stakeholders? How do you make sure you identify and accurately represent the requirements? How do you kind of get what you need from that stakeholder who doesn't speak that gateway language, but really speaks their science language? And then, you know, John, you can get kind of your aspect from the scientist hat.
Oh, sure, I can start. It's a big challenge. I'll say that up front, trying to understand the requirements for a portal is really difficult. And things that seem small in the scientist's mind can end up being really big. You know, they may initially come at you with an architecture that is sort of batch and asynchronous, and people do things in the background and come back, and so you build your portal around that type of technology. And then either because they didn't even think of it at the time, or because, you know, a lot of these portals have, you know, the initial grant that funds them is 4 or 5 years, and that's a long time. I mean, I don't know what you all were doing 4 or 5 years ago, but I had a different technology stack that I was working with. And so, you know, new things will come out that suddenly, to be relevant, this portal needs to do some new capability, and that may follow a completely different computing paradigm. So I would say that's, you know, that level of requirements is always challenging. We've kind of tackled this. I think we've been more successful in tackling this by really having a broad spectrum of underlying technologies that we can throw at the problem. And so that, you know, these sort of tricky requirements that come later on, we can sort of compose a solution rather than sticking to just kind of one monolithic approach. But again, that can be challenging because of some of these projects are small, they have small budgets. So yeah, with requirements, I think that's one thing. The other big thing that we've run into is a lot of professors are accustomed to like the publishing model. So if you have a project you're working on, you might expect to publish on it, say, once a year, right? And the rest of the time you're gathering data and preparing and all this. And so sometimes when they apply this to a portal, they think, well, we'll update our portal once a year. It's like a publication. And we don't want any bugs in the portal because we wouldn't release a manuscript without going through and combing through the edits. And it makes the portal look like, you know, if they have their way, it makes the portal look like it's not maintained well because it's so long between releases. Your community doesn't see that incremental progress. And it can be really hard to train your PI that, you know, things need to be in these 2-week schedules or something that's much more rapid, that's not going to have everything solved, but have this sort of incremental progress, and to be available to everyone in its current state as it is. You know?
I do agree a lot with what you just said. One of the main issues that I've seen, it's about empathy, and us having empathy with the stakeholders and the stakeholders having empathy with us. And it's mainly about the different things that we know about, right? Like different domains. So as John was saying, like they know a lot about their own like academic domain. We know a lot about these different technologies, but they both just behave in totally different ways. Like for instance, the publication aspect of it. But also there's these other different things that sometimes the stakeholders, they have different types of requirements, which they're not necessarily intuitive to us to actually implement. But these are things that are very important for that specific context or for that specific domain, which is something that sometimes it's hard for us to understand, wrap our minds around how come people do things this certain way. But that's one thing that we need to do a little bit better, which I think every day we're kind of being better at it, which is being empathetic with all these different stakeholders.
Yeah, I agree with Josue there. There's a lot of figuring out. The scientists need to communicate to us what they need to get their work done, but they may not know what they actually need to get their work done, if that makes sense. So we need to suss out what they want and what they actually need to do their jobs. And I think that fitting existing infrastructure into some of these newer projects is also a challenge that we're still trying to figure out, because we have you know, infrastructure that may have not been intended to accommodate all this different stuff, but now we have all of these different new projects coming on. And so we're working to build that out and make it more flexible and better serve different communities.
So just to build a little bit on what you said, what strategies have you guys used to really bridge that language gap? You know, kind of what practical tips do you have when it comes to how to make sure that the requirements are effectively communicated so that when you get started, you're really all on the same page?
I would say having kind of experts that work at TACC and sort of know the development and have maybe worked with gateways before is like a really big deal, because I can't imagine what somebody in biology would need out of our portals, but someone who is a biology person but has also worked with portals and worked with TACC before could probably better explain it to me than me trying to figure out what, you know, what somebody might need.
Yeah, I'd agree with all of that. I think also even for, I mean, initial portal requirements are, you know, they're huge and tangly and largely unknown sometimes. But even smaller like feature requests are also sometimes really difficult to pin down. So I think one thing, this is one place where, I mean, nobody likes meetings, but I think this is one place where more communication and more meetings are actually a good thing. I've definitely learned to like ask questions and keep pestering the, you know, the stakeholders of a feature to really figure out what it is they actually want.
I'm sure they can spell it out for you before they ask you to do it.
Right, yeah, spell it out, you know, be as explicit as possible. And not, you know, things can definitely still go wrong afterwards. Yeah, I definitely recently learned that on a feature request to basically build like a wizard UI for one portal. So they wanted, you know, this multi-step wizard form type thing to basically be able to submit a job through Agave, and it's fairly straightforward. That's pretty standard stuff to do. And they had some back-end Python code in order to, you know, populate some of the information that goes in this wizard. But it turns out that was all Python 3 code. And our portals right now are Python 2.7. And that Python 3 code is also calling Lisp code on the back end. So it was very, very tangly mess. So I think the lesson learned there is, you know what you're getting into, know what you're trying to integrate. You know, I should have looked deeper into their code base to figure out what was going on before trying to estimate time and things like that for even a small feature.
Yeah, I definitely agree. Communication is key. Meetings are important. Even whiteboarding, spelling out, making sure that we're speaking the same language, because, you know, PIs, stakeholders, researchers may speak differently than we do. The same thing might mean different things in the context that we think we're speaking in. Also understanding the user base, the community that's going to be using the software. Is it going to be a limited set, a huge set? Is it going to be expected to grow over time? Understanding all those things helps us to build a better product up front. Another big thing is managing expectations, making sure that stakeholders understand that this is a process, and that even what they think they needed at first may evolve over time. I think managing expectations is very important, especially some things take longer, and it requires the engineers and developers building those portals to go back and say, well, I think this would be easy, but would it actually be as straightforward as I think it is? So we can go back and talk to people who provide services that are available to us, and can we meet this use case or not? And if so, is it as easy as I think it is? Maybe do smaller prototypes so we can understand whether or not we can do what we would like to do. Because developers, well, we tend to be very, very optimistic, and back to bite us from time to time.
That's also very interesting about prototyping, because as developers, or at least I, like to do like proof of concepts. But these different proof of concepts, they usually tend to work on small amounts of data, or just these different examples are really not anything, or they're, as they say, like almost but entirely unlike the real thing. So the only thing is that once these go into production with the proof of concept, everybody says, this is great, this looks great, this works great. But when actually when actual users start using it, we realize that the amount of data that they're trying to upload or they're trying to manage and all that, it's just way bigger than the ones that we were doing in proof of concept, because proof of concept is just that, right? So that's something that, I mean, it kind of also falls into having better testing, more stress testing, things like that. But then again, well, it's on both sides, because we need a little bit more information about the type of real data that the users are going to use from the stakeholders in order for us to write better stress testing.
Yeah, please do. And come get, wait, I want to throw the cube at you. Hold on. I can't throw that far. I'm not a football player. You might, I'm going to pass it. Okay.
Yeah.
Thank you. I've now accomplished my goal for this conference.
So this is kind of along the lines of where you were talking about with the proof of concept. I was wondering if you guys have any project tools or software, anything that you kind of rely on to make sure that you are on the same page with your clients before you get into any of the coding.
Well, yeah, we do a lot of mock-ups, what we call mock-ups, which is just like different drawings of how things are supposed to kind of look like. And also it gives you a better kind of feel of how the user experience is gonna be. Not always 100%. There is always just a few things that are gonna change, or a few different things that maybe whoever did the mock-ups didn't realize that you can't actually do it, or some things, right? There's always some small differences, but we try to always do extensive mock-ups and try to show that to everybody involved in the project, so that we're all, at least that we all have an image in our mind on how the finished product is gonna look like.
With my developer hat on, or my organizing hat on, I would say kind of vision and requirements documents. I know, kind of we don't like to do that phase, but having a formal document that scopes out like, this is what phase 1 of the project is going to look like, this is what phase 2 of the project is going to look like, from a very high level, and make sure everyone like has signed off on it. So in 6 months when they come back and yell at the developers that we didn't ask for this, or what happened to these 10 things that we wanted in phase 1, and you're like, none of that is here.
Yeah. Right.
So I feel like some sort of documentation early on is pretty important. You can grab the cube.
Should I?
Yeah, she's right there.
Oh.
A few rows up from you, someone has a question.
Oh, sorry. Do you want me to
Toss
throw this or?
Woohoo!
Okay. I play soccer, but
This is so much fun.
not this.
I am going to buy one of these and take it to every conference with me.
So yeah, just following on the requirements document, that sometimes it is overwhelming for developers to write a lot of documentation, and from the Agile development that we do, and probably you're familiar with that, but just write short user stories that just tell, here are the few use cases of how the user is going to interact with the system, and it just maybe a sentence or a short paragraph for every use case, and it's a lot easier to
digest.
To digest, yeah, to first to write and then for also researchers.
Yeah, you don't have to write a novel.
To agree to. And that was just a comment, but a question. So when you're working with a stakeholder and you're building a new feature, are you considering building something that will be reusable by other researchers? I mean, how much this falls into place and how often you can do that? Because I imagine that if not, it's very, the bandwidth might not end up having all the bandwidth.
Yeah, I think in general, we try to make everything reusable, because a lot of these projects have very similar needs. And we are working on a core portal project right now that basically has everything, and you'll just clone it out and, put a theme on it and say, this is, the Rocks Gateway or whatever. So that's very important, and it's a major focus in our work. It's kind of hard to do that sometimes, especially when clients sometimes the domain sciences are weird and they want something really specific, but yeah, we definitely focus on that.
Yeah, I'll just add that, yeah, we're trying to, yeah, like Carrie said, kind of generify what we do to be able to make it reusable and easily deployable for other projects. And I think, yeah, I mean, a lot of the customization comes in at kind of the applications level as to like what applications each, you know, new tenant or new group wants to use. So those are somewhat, you know, more easily, I guess, customized or launchable. And yeah, we've got a bunch of, you know, libraries that are reusable that we can use to talk to different systems. It's inside TACC, you know, authentication and Agave and things like that. So all that is also kind of reusable. We try to keep that up to date and reuse it wherever possible. Yeah.
So building up a little bit on what you mentioned with technologies and stuff, one of the next topics we can talk about is kind of how do we fit the technology pieces together? How do you make good selections for technology tools? How much does the stakeholder have a say in that? How much do you guys have a say? Kind of how do you effectively pick the pieces?
Yeah, this is an area I really think we've improved a lot since I joined TACC. We used to sort of we would approach it like a burger stand, right? That, you know, you were going to get a hamburger, you could choose the toppings, but we had sort of this narrow band of capabilities that the platform that we had could offer. And then when you would switch paradigms or something like that, it became very difficult. And this had a lot of different drawbacks, just to go in specifically, right? We're building on Agave, the Agave API, which we still do and we love. It's a really powerful API. It takes some of the complexity of interacting with the HPC systems that we commonly need to do scientific workflows, and it separates that out from the portal layer. This has probably been talked about in other talks at this conference. But that's been a really nice separation of concerns, especially since we know we're guaranteed that the HPC systems are going to roll over every 4 to 5 years. And it lets sort of it's an open source project that's got a number of developers behind it. The project, the portal that you're working on doesn't have to sort of make that lift to keep the code up to date. So the separation of concerns has been there. But as time has gone on, we've sort of had these essentially different ingredients that we can apply in different ways. So we have Agave to handle a lot of the HPC and batch computing. We now have a different set of APIs called Abaco that handles this kind of small compute, event-based, kind of quick turnaround concept in mind. We have stolen as many technologies as we can for interactive computing. So we use Jupyter a lot, or RStudio or something like that. That's a great way to provide a fairly expressive interface that's not as much of a learning curve as a command line. And in fact, it's already in use in a lot of labs, at least in the domains that we've been applying it towards. And we have some other kind of smaller services, the back end. We have a GitLab to manage code that's not internally managed. Other stakeholders in the project can actually develop an app, and we have a place where they can store it. We have some methods and some standards internally that they use to convert that into containers, to run some testing suites on it. And we have a whole lot of things that we don't need to maintain the underlying code base, but we can steal that to create this ecosystem of ingredients. So if someone comes in and says, actually, I need now to run, to search data to pull out some subset and go run this in Spark or Hadoop or do something crazy, or I need interactive analysis. We have all these ingredients where we can start piecing them together and saying, all right, well, we can use one of these Abaco actors to start pulling out data and putting it into a data frame. We have some very expressive interface people can start to build from, and it just sort of moves the burden away from these things that we have to maintain monolithically. So I'll say that's one of the ways that we've gotten better at being responsive to changing requirements in a way that's sustainable and maintainable, is really having a portfolio of ingredients. So instead of a burger stand, we're a kitchen, and we can kind of cook up any dish.
Yeah, I also agree with John with the whole thing that we have all these different, all these really big menu of different technologies that we can use within TACC. There's a lot of different problems that are already solved. But it is just about picking different things. But then the thing is that that's something that's really good, and it allows us to tackle any problem at any time. But then there's a lot of planning on top of it, because then you have more options. So the question sometimes becomes about, where do we solve this problem? Do we want to solve with this tool or with this other tool? Which one is going to be better? Which one is going to be faster? Which one is actually perfect for this specific problem? So that's actually something that then becomes a thing about, well, you really have to be acquainted with the entire menu, how different things react within each other, which is what we sometimes call like highly distributed systems. And then I think Dan once said that the only thing that means is that there's more places where things can break, which, I mean, it does, but it also means that there's other things that you can use in order to avoid those things to break. So it's kind of like a scale that you have to figure out. I mean, it's really good to have all these different, this big menu, but also there comes a point that you have to say, well, do I want to bring yet another technology into this project, or solve it with the tools that I'm already using here? And there's really no single answer. I mean, there's a bunch of meetings always about that, and where and how to solve different problems, which is the interesting part about building these different tools.
Yeah, I agree with both. So it's kind of a double-edged sword. We have a slew of tools available to us, especially with the explosion of open source software, both in-house and external. It's very easy to clone a repo, modify some stuff, and then get going and running, right? And there's always the temptation to use the latest and greatest tool. But as fun as that can be to learn new technologies, somebody has to support that down the line. Projects may end up dying, they may end up stalled, or it may just end up being the wrong tool for the job. There's a lot of promises in open source software that end up not being kept, or they change drastically. You know, we could make an example of like Angular has changed dramatically in how you use it and how it's implemented and its interfaces over time. Fantastic tool. It was very nice when it came out. Now there are other technologies that do similar things. But do we want to, like, if we were to look back, would we still use it? Maybe in some cases, maybe not. So it is definitely a tough call with so many options, which ones to choose, which ones to use. And I agree with Josue, certainly. Which tools do you have expertise with? Which are proven entities and quantities? And what do we actually need to do the job? Not what would we like to play with because it looks cool.
So to expand on that question a little further, oh, sorry. Shreyas, you want to grab the phone mic?
Oh, yeah.
Thank you.
So yeah, a follow-up to that would be, how do you guys go about incorporating new tools and technologies into your toolbox, into your ingredients list? And how do you, how does something make the cut? And how do you support that? How do you factor in bringing in some of these new tools? And when do we sort of decide, okay, this is something we want to spend time doing? And do you guys factor in time to experiment with these things into building the portals as well?
Right. So there are a few that are set entities that we use. We know we're going to use regularly, like the Agave API that John mentioned. There are others that early on, a few years ago at TACC, we experimented with and tried, and we have decided and whittled out tools that we know won't serve the purpose or we don't need to use at this point. So a lot of it is experience and looking back at what has worked. So those issues have already been resolved to an extent. And at least for me, I always try to look at new technologies with some skepticism, like make sure that it's robust and not just it's effective. It may work really well for a certain purpose, but if it breaks constantly, then that's going to defeat the purpose of using it in the first place. So answering that question it's a tough thing to do. I think with experience, as you move, you learn what does and doesn't work. And I think at TACC, we're at a really good spot where we've experimented with a number of different technologies and we know what works for us. And we try to take on new technologies only when we're fairly certain that they're gonna meet the needs and they're going to do it consistently.
Yeah, I think just to follow up on that, I would add, I guess there's kind of like a delicate balance between trying to keep up to date and also, trying to maintain the code that's already there. Like Alex said, yeah, we've got a bunch of Angular 1 point something code, tens of thousands of lines of that, and we would love to, migrate it or upgrade it to either a more modern Angular or something else. But it's a good question as to how we actually do that, and we've talked about it, and we're trying to figure that out. But one thing we did was kind of like look at different technologies. So we've looked at Angular 6 versus React, and kind of talked about what are the upgrade strategies, how do we do that, which is the least painful, and what code actually looks good, and which framework do people prefer. So there's definitely a lot of discussion among the people working on the project as to who wants to work on that stuff.
So do you guys factor in some experimentation time into your projects, or what is the context where you get to play with some of these new tools?
Do I actually have like an official playtime?
That's a good question. I would say it maybe depends on the project.
Yeah.
I think as long as we come into it with some identification of risks and how to mitigate those risks. I mean, I don't know, is there formal playtime? No. I would say it really just depends on the project and the kind of ramp up it has. If it's a project that we're familiar with the kind of technology it needs or the kind of work it's going to be, usually we pick a technology stack that we're most familiar with. If it's a new project that's more research focused, sometimes we have more flexibility with what technology stack we can pick. So it really is kind of a project by project, stakeholder by stakeholder decision that gets made. Certainly we've sometimes picked technologies that have not been the right strategy. It's a delicate balance between using what's great, using what your staff can learn, and using what you can continue to maintain. If you have one person with that expertise and that person leaves or gets hit by a bus, you can't have your project really hinge on that alone. So I don't think it has a straightforward answer. And I think we've all been in the position where something, and it's like, darn, this doesn't feel like the right decision. And in some projects you're stuck with it. And in some projects you can pivot and go a different route.
And we also have meetings like once every couple of weeks or a month where people just kind of talk about something interesting that they've seen or working on. So it's kind of an opportunity to, I guess, show off new technology, or, if you want to play with React or something else that we're not using, you can show it off and say why this is better, or why this could be better.
Right. Along the lines, we try not to make decisions in a bubble. And I think that's the big thing, is we try to really, as a team, as our projects have grown and our scope has grown, in a bubble where they're at least as best informed as they could be.
Yeah, and these guys have done a great job on sort of streamlining their tech. They all, I mean, Django is big right now at TACC, and they all produce libraries and components that each other can use. It seems like there's a lot of good crosstalk between developers. There's a lot of good dissemination of ideas between projects. As one who is often more in the PI stakeholder position on these, I feel like one of the things that we've learned on this, again, technology stack is to take some pressure off of the portal. There will never be a Facebook for science. The entire concept of Facebook is that you have a common set of tasks that everyone in your platform is going to want to do, and that's all that you need to do. By nature in science, every single user is trying to do something novel that no one else on your platform is doing. If you luck out, and this is on the experimental side, where the computational pipeline is going to be the same, then they can fit happily into a box. If they're not, if they need to do some new type of analysis or some new type of something, then they need a way to express that. And if all of that is going to be in a custom UI, you're putting a lot of pressure on yourself. So if you look at the UIs that we generate and the views into things that we generate, they have gotten more sophisticated, but in many ways they do the same thing. 6 years ago, we were showing views of data. We were letting people run jobs with, kind of inputs and parameters. We were doing job status and things like that. And there's been a lot of cool innovations on using search and some really cool features that are now embedded in the UI. But at the same time, a lot of the innovation has come on these back-end ecosystems where they're interacting with something that's not a portal to make these kind of custom munged data sets that you and your collaborators can view. We've incorporated Slack notifications into job execution. And we can do some of these weird oddball things by taking that out of the portal and putting it into something else. And a lot of times, at least in the most recent projects we've had, the people maintaining this something else code is the user community itself. They have an idea, they're able to express their app in terms that our portal can understand. And now we can have literally this platform that can grow and scale with the user community and not with the developer community.
Okay, awesome. All right, so kind of along those lines of technology and picking the right stack, one of the things about is keeping current. How do you stay up to date on the evolving on security issues, on maintenance and updating, and what were kind of the lessons learned that you've had throughout the years?
Well, I think keeping updated on the whole technology topic, it's always hard. It's always changing, and it's something that it's really not that old. I mean, software developing started in like the 50s or something like that. Well, it was in 54. So yeah, it's not that old, so it's still changing. And one of the things that at least I found that helps me out a lot on keeping updated is going to different conferences, on talking to people, and talking more about talking with other people that are using the same tools that you're using or similar tools. That way you can get more ideas, different ideas on how other people are solving similar problems. The other way to also do it is to just go around the office and talk to other people outside of your group, because there's always people working in solving different problems. And sometimes maybe a problem that you have has been already partially solved by some other group that you usually don't talk to, like on a day-to-day basis. So that also has helped me out a lot. And lastly, I guess, another thing that's also very helpful, it's reading a lot of different things online, like blogs, trying to see, like just trying to experiment with all the different things that are out there. I mean, there's not always time to do those different types of experiments, but whenever there is time, most times actually, they do yield something really good, because maybe you're not gonna end up using that new technology, but you learn something new about the technologies that you're already using and how to solve something that maybe you're not able to solve right now.
Yeah, I'm just agreeing with this way. It's just talking to people a lot and paying attention to what people are using outside of your office too, like talking to other developers, whether that's conferences or meetups or online or whatever. Just try to stay plugged in, basically.
Oh, Shreyas, can you toss the mic up, Lena? Oh, so close.
So close. Yeah, I think like Josue said, there's definitely a lot of interesting people at TACC doing interesting things. So talking to all those people, you can get some good ideas, and also maybe shave some time off of your end as well. Just the other day, we've got this one project where they've got these huge electron microscopy images. They're like 10, 20 gigabytes per image or something. And you want to be able to like show them in the browser. So there's lots of different ways you can do that to like pre-process them and chunk them up. But I was talking to one of the Viz Group guys, and he's doing something maybe where we can like chunk them up, I guess, on the fly and basically send them directly up to the browser without having to do any pre-processing and things like that. So there's always something cool going on, and if you talk to people, sometimes you can offload your work onto them.
So I have a question about if you guys follow any software development methodologies, like do you team up, do you use Agile or anything like that?
Let me tail end on this question. I will say that we do use like the academic variety of Agile, at least within
What we
the,
like to
the
call it.
broad project, where it's not necessarily daily stand-ups. A lot of times our time is split between projects, so it's a little bit less frequent. But we are huge fans of Agile in general as a communication vehicle that has, both a shorter commitment on meeting time, but also a pretty high degree of bandwidth. If I can finish though on the maintenance question, then I'll let more intelligent people speak to the development process. The maintenance load on some of our different projects has varied widely. We have had, one project where we used, we had a requirement that some of the external stakeholders were going to be adding kind of posts and text and updates and things like that asynchronously. So at the time, don't judge us, we use Drupal for the underlying infrastructure, and no offense if you use Drupal. But that is not a code base that ages with minimal maintenance, to put it that way. And so it's a portal that's built on that type of infrastructure where there's a heavy server component, where it is open source, but it also has plenty of surface area for attack and security issues. The maintenance load has been high. We had another project that's built in, it's actually in Backbone, so it's now a very dated, well, I think it's dated, library. I'm sure how we use it is dated. The model that we used though was that the portal was really just a client. There was very little server side. Everything was in APIs. So you would load the page, which would download the client, and then all of the interactions were happening through some sort of API interaction. The maintenance on that has been so shockingly low. We've maintained the APIs, that was sort of core. And so this added portal layer has aged very gracefully, kind of in an unfunded period. But it is really tricky in academia because, the funding agencies don't like to fund portals in general. And they especially don't like to fund maintenance of portals. They don't understand why, if you're not building something new, it should cost anything to do the maintenance. And so this thing where whatever you write it in is going to age in 4 to 5 years, which is actually pretty predictable. It needs to be completely refactored. It's hard to get people outside of the portable development community to understand that. And hopefully collectively as portal developers, that message can change over time where they have a better understanding. But it's definitely a tricky task. So we can go to Agile development. Sorry to derail and take a step back.
All about methodologies, yeah, as John was saying, we do try to do that. We do try to use Agile, but because of the funding method, as John was also mentioning, and the way that our time is managed, it's not always easy to do that because we're not always just working on one product. There's always multiple products that we're working, and all of those different products they need to be ready. So that's the hard part. But what we're trying to do more and more every day is just to put more checks on us, like write more tests and have more pipelines and more automated things to check the things that the code and everything that we're doing to check that everything is correct. Because of these different projects, they're actually very, very big, as everybody knows, and sometimes just changing one thing, it trickles down to many other things that you're not always gonna realize right away, which it kind of comes hand in hand with the whole maintenance things. Because also some of these portals, as John was also mentioning, just by the nature of it, our users are trying to do novel stuff. So that means that sometimes the initial requirements by the third or fourth year, they're just totally different. And we have to move in the same way that the users are, or that the user requirements are actually changing and evolving. And it's not because things just outside of these constraints change. It's just because when users start to realize that they can do different things in these portals, they want more things on top of it, which is just nature. And it's really our job, because our job is to make their workflows easier to manage. So the only thing is that it's really difficult to try and see what's going to come in the future. So really, the only thing that we can do is just evolve as fast as we can, with our users, and hope for the best, really.
Yeah, I would say the only thing that I would add from my standpoint is not to have process just for the sake of process, but to find that balance with just enough process so that it's productive, so that everyone knows what's in the project and can stay on the same page. Because like they mentioned, everyone's kind of time slicing. So if you step away for a few days, you don't want to have to come back and be totally lost. So, you know, just enough process to really keep everyone on the same page.
I'll add a little bit to that. I'm on different projects that do slightly different kinds of Agile to varying success. So the methodologies help provide a framework in a way, but it really depends on how you use that framework. You can't just say, oh, you know, I'm using Agile, so it's, you know, it's going to definitely work like this, and it's definitely going to help us be productive or whatever. It's really dependent on the people and how you organize time and stuff. So,
Questions? Ready? Okay, this is kind of far. Nancy, watch out. Let's not take out my PI. Sorry, Nancy. Yeah. I'm fine. I am no Colt McCoy.
So do you use continuous deployment? And if you do, how do you deal with the, you know, the NPM breakage constantly or the pip breakage constantly?
Well, that is something that it's always hard to deal with. And in some projects, we are actually containerizing most of these things. So by using an image, that's one solution. Another one is that, well, we try to not, well, we try to have these different stages whenever we're going into production, right? So if something is broken, like PIP or NPM, we're first going to try it on staging, right, or QA. So if that doesn't work, then we're going to hold that release off for a bit. But yeah, that's definitely one of the biggest things right now, because that could basically just break everything, and that has happened before. But I mean, sadly, today we live in a reality that we just share everything, as Alex was saying, because of open source and all that. So we have to kind of blindly rely on other people and they're willing, or if they're willingly to actually keep maintaining those different packages.
So pip freeze is your friend. Lockdown to versions. It's nice to say ... versions are safe, right? Well, it depends. It depends on who's doing the development. It depends on how mature the project is. Is it internal? I mean, there are a number of different factors, right? I try to lock down my projects, the versions, and keep them there until some real reason to upgrade comes up. I think that's the key. At least it has been for me, because it's so easy to just leave things open and then they upgrade automatically, and all of a sudden, a year later, your project doesn't build. And what do? Yeah, sussing out all of the different dependencies, and it sounds like you may have had to deal with some of that. is quite a challenge and far more time consuming than it would appear to be. So
yeah. I think just expecting things to break, even if you haven't touched them. As we have had instances like that where, like, we didn't touch anything and nothing is working. That's because someone else touched something else that we happened to build upon, and everything of ours breaks. So I think just expecting them to break, like especially as soon as someone goes on vacation, what they're responsible for will inevitably break that hour. You know, so building that into your time and understanding that it's part of the process. It's hard not to get frustrated when things break, but understanding that it happens and strategies to work through it.
So on the subject of pip freeze, do you pip freeze every program and deploy binaries or virtual environments or separate Docker containers for each program?
We do Docker images that are built for like each version that we're deploying, and also virtual environments in Python that are frozen to that version. And yeah, we've also had Yeah, we're trying to do a lot more with, continuous integration, definitely with things like Bitbucket pipelines. So basically on every push, we'll run, a set of unit tests. And that'll give you, instantaneous feedback. If your NPM packages are not working, then you'll immediately know, and it'll just fail. And also on every pull request, we're doing a pull request, development process so that each new feature, each bug that's addressed gets a pull request. The tests run. If they fail, then the pull request is, declined automatically. So that's been working really well, and it seemed to have mitigated, a lot of those problems for sure.
So I deal with this every day, so I'm just,
Yeah.
So when you build a Docker image on Travis or whatever you're using, do you find timeouts and pulling things, or do you build your Docker images and just add your stuff to it?
Well, we actually build our own images, right? So we use a base image, usually it's a Python 2.7 image, and then we add our own stuff to it, and we build it locally in one of the servers or the VMs, and then we push it into the Docker Hub. So then every other node that we have in production or QA or whatever it is that we're pushing into, we're just pulling from that hub.
Yeah, I think they've already got it, but man, things got so much better when we containerized our infrastructure. And then we have a staging environment. The more that staging environment deviates from production, the more we get in trouble. So we've carried the discipline of keeping those pretty close. And that's been great. We containerize all the way down to end applications. So our portal will launch things that run on the HPC system, and those apps running on the HPC system themselves are containerized and ideally involved in continuous integration with a test suite. So we have lots of visibility all the way up and down the stack. And that's kind of the other thing, that with a distributed infrastructure, there's a lot of pressure because, like Maytal was saying, your code may be perfect, but you're depending on someone else. And so having this sort of carefully untrusted relationship with things so that you can be notified when something is going down or air out gracefully from the user's perspective has been important too.
Who wants the cube? Oh my. Hold on to your cups. Oh, nice catch.
To build on that, we've struggled with this a little bit. How do you deal with, and what are your policies for downtime? So, I mean, you all work 9 to 5s, right? And, downtime, does downtime happen during business hours? Do you email users? What are your, recommendations or suggestions?
Well, we usually have a backup plan. Always, there's always some type of static site that's going to say we're under maintenance or something like that, just so we can show something, right? The other thing is that we do have a lot of different monitoring. Thankfully, there's a really, really great team at TACC of operations and DevOps, so they help us out a lot with setting up these different monitoring. We're also using things like New Relic in order to figure out whenever there's a downtime. And if it's after 9 to 5, then usually we try to document a lot of the different kind of plans that we have whenever something goes wrong, which is basically just turn it off and on again, right? But with nicely described steps. So if that doesn't work, then some of us will usually get a call. And then you will have to, jump onto your laptop or something like that. But we try to document everything in a way that nobody is indispensable to be there, so somebody can just restart everything and try to see if that was it.
So do you mean unexpected downtimes or expected maintenance?
Expected, actually.
Planned maintenance?
Unexpected is important too, but expected. So I mean, say that you have just 15 minutes of downtime that you can't get around during business hours.
And is this more on communicating to stakeholders and users?
Communicating to users. Do you email them every time?
We use, well, it's not really an ad, but we use Status.io or something like it And then you can schedule the maintenance beforehand, and people can subscribe to it because that way they can opt out if they don't want to know.
Right.
The other thing that helps is having a page where if they're experiencing problems, they can click on a button and see if there's a maintenance or not.
Yeah.
So, and that get it into the portal itself, so not their email inbox.
And do you try to give like 7 days notice or?
Tuesdays are generally maintenance days. So
Okay.
a lot of times there's an expectation that if things are going wrong and people go, oh, it's a Tuesday, and then they'll kind of figure it out.
Gotcha.
But so we restrict it usually to 1 day a week.
Okay.
So planned maintenances will only be Tuesday. And then as far as sending out notices up front, you're going to have to just ask we try to ask our stakeholders. A lot of times they don't need a week in advance, a couple of days, even 24 hours if we really, put a sorry, but we need to do something kind of in there is fine.
Right.
Yeah, I would say on some of our bigger projects, there is like a user news that people subscribe to, and there's an offsite backup to where we point to that when we have downtime. So there's no actual user interruption in our downtime, but that's usually for the bigger projects. There's kind of more stringent, higher expectation of uptime. So there's an offsite copy that's not at TACC that runs and gets updated, and we point to that whenever we have maintenance.
And also for the bigger projects like Designsafe and SD2E, they've got their own Slack communities. So, everybody will get an email, but nobody really checks email these days, but most are actually on the Slack channel. So,
Right.
so we'll send out a broadcast message to that saying, hey, reminder, we're going to be down for the next hour or something like that.
Thank you.
Yep.
Okay, we only have like 1 or 2 minutes left. Anyone have any last questions before we thank our panel? Okay, thanks everyone. This is a lot of fun.